Well, juniors, this is section 8.5, which is asking you to solve exponential and logarithm equations. In both cases, if you are trying to solve an exponential, you'll end up using a log to do it. Or if you have a logarithmic equation, then you'll use an exponential to solve it. So, the first thing, and this is basically the only notes that you need to have, is this very top piece. Get an exponent alone, then take the log both sides. Get logarithmics alone, change it to an exponential form. So if we look at this first example, the exponential is by itself, so I'm going to take the log of both sides. Then I'm going to use my properties of logarithms. That power becomes the coefficient out in front. Then I'm going to get the x term alone. And then finally I'm going to divide by 3. Now, all I have to do with this is take it to my calculator. So, since I need to slide the thing over just slightly, and we go to the calculator, you have to keep track of numerators and denominators, and since everything is just plain log, that means it's base 10 and I can use my log button, log of 20, and then be very careful about that second parentheses, because if you don't have it, it won't give you the answer you expected, divided by, then since I have two pieces in the denominator, I need a parentheses, 3 times the log of 7, and I need double parentheses to work it out. And then you get a decimal answer and you round to whatever the book tells you to do. Now, that's one type of way of solving exponentials. They're also going to ask you to solve an exponential using your graphing calculator. In this particular case, we are using, I need to change colors, 6 to the 2x equals 1500. So, this is the equation that we're going to solve. We're going to go to the graphing calculator, we're going to go to the y equals, and we're going to change function 1 and function 2. Function 1 is going to be my left side, so I'm going to have 6 caret, and then since I want both pieces as part of my exponents, I need parentheses. And in the second one, I put 1500. Now, if I graph this right now, I'm not going to see anything because, or I'll see one equation, but I won't see the other one because I need to go up to 1500. So I'm going to change the window, maybe, and I'm going to make my y max, I'm going to make it 1800. And then I'm going to redraw it. And now you can see the point of intersection. To find that point, I go to my calculate functions here, which is second calc, and you look at number 5 on the intersection, and you say the blue one is my first equation, hit the enter. Then the red one is the first one, hit the enter. Then it's going to ask you a guess. A guess is so it just kind of keeps close. I'm going to say 1. I have no idea what the answer is. And then it tells you the answer is 2.0407. And again, you round to whatever they ask you to do. So the first part of your homework is going to ask you to solve exponential functions. You're going to solve them 2 ways. Once, by taking the log of each side after the exponents alone, and then the second way is by using your calculator. Alright, so that's the first way that we're going to solve equations today. Now, if we go back, alright, now we want to solve logarithmic. And again, if we're going to solve a logarithmic, we need to get it alone or a single logarithmic expression. That's very important. So if I have this expression, I know the base, if it's not written, it's assumed to be 10. So if I rewrote this in exponential form, I'd have 3x plus 1 equals 10 to the fifth. Well, we know what 10 to the fifth is. It's 1 followed by 5 zeros. Then I'm going to add a negative 1, and then I'm going to divide by 3. You can test this one out by putting this number times 3 plus 1 and hitting the log of that button. You'll get 5 for an answer. Now, in this second example, notice we have 2 log expressions. So we need to get it so we have a single log. We know the 2 is a coefficient, becomes a power, and the minus means that we have division. So this is going to be the log of x squared over 3 equals 2. Now again, this is a base 10 number, so we'll have x squared over 3 equals 10 to the second. I've changed the logarithm to the exponential. And now when I get to here, it's just basically solving. So I'm going to multiply both sides by 3. I'm going to take the square root. So that'll be 10 square roots of 3. It would be a plus or minus. The only trouble is we cannot take the logarithm of negative numbers. So our final answer is x equals 10 square roots of 3. Now, the only problem with this type of an example is that we are limited to base 10, because that's all that common logarithms are dealing with. So we need one more piece of information, and that's over here under the black, and this is the change of base formula. The change of base formula is log base b of a equals the log base whatever I pick of the big piece divided by the log of the same base of the base I started with. So if you look at the example that I have here, log base 16 or log base 2 of 16 would be the log base 10 over the log base 2. I picked those two because I could use my calculator. And if I would take the log base 10 or 16, make sure you put the parentheses around it, divided by log base 2, I get 4, and I know that's my answer. All right. To be honest, that is the entire lecture that we have for today. If you'll go to your book, in the first group, 1 through 12, you are asked to solve exponential functions. Get the exponent alone, take the log of both sides. And it says round to 10 thousandths. 10 thousandths is 4 decimal places. 13 through 16, you are doing the same thing, except you're solving using your graphing calculator. 25 through 32, use the change of base formula to evaluate each expression. Okay, that part's easy, because you can just slap it in your calculator on number 25. You'd say the log of 9 divided by the log of 2, and you're good to go. Now, the answer you get is an exponent, but they want you to rewrite it in base 8. So let's look at 26. So, in your calculator, you're going to put the log base 8 over the log base 4. And again, I'm using my log button. I'm going to use basically base 10 anytime I have a chance. So in my calculator, I have log 8 divided by log 4. Notice I put those extra parentheses in there. You forget, it gives you a wild answer. And the answer is 3.5, which we should have known anyway. So the answer is 3.5. So that's the first answer they ask you to do. Then you're asked to rewrite it as a log base 8. Well, you don't know what this value is, equals 3/2. So we got to kind of think backwards. This value is whatever 8 to the 3/2 power is. So I go back here to my calculator. I type in 8 caret, and then I'm going to put in 1.5 power. And I get a wild number. And that's what they want me to write in there. So in here would be, I lost it. So your second half of your answer is this one. So the first one we use the change of base to find the actual exponent. Then to find out what this value would be, base 8, I went to the calculator, I took my 8 to the power, and then I found my answer. The whole piece here is the solution. Alright, that's 25 through 32. 33 through 41 are solving logarithmic problems. So you're going back to here, where you had to solve logarithmic ones. Same thing on 42 through 47. When you hit the mental math ones, guys, you cannot use a calculator. Alright, if you have any questions, make you get a hold of me, email me, whatever it takes. So, today we solved exponential and logarithmic equations. Basically, we use their inverses to solve each one. Good luck.